Now this problem, at first glance, a lot of students skip over it and don't see that it is a difference of cubes, because that 1 doesn't make our brain say, oh, that's something cubed. It's really large, because our brain says cubed is big. Well, 1 times 1 times 1, as many times you want, is still 1. So we've got to be careful to recognize that this actually is a cube. So y cubed gives it away that, hey, we're looking at cubes. But this is not the difference of squares. It's the difference of cubes. So we got to say y is being cubed. That's my first value. And then the 1 is being cubed, so minus 1 cubed. As soon as I recognize it's the difference of cubes, then I just throw it through my formula. That says it's the first term, the a, and the second term, the b. So it's just first term, second term. And then first term squared, so y squared. And then you multiply the terms together, y times 1. I'll actually write it. I know it's just 1y. And then the last term squared. That's the formula. And then we just fill it in with SOAP. And the SOAP says you put the same sign, opposite sign, always positive sign. And then we just clean it up. So we have, I mean, it's already right. You don't technically have to do anything, because everything I wrote is actually right. It's just you wouldn't write 1y. We wouldn't really need to write 1 squared, but I'll rewrite it just for, clarity's sake. It is y minus 1 times y squared plus y plus 1 for the fully factored best form of our answer. So now we're going to take a look at factoring sum and difference of cubes that have higher degrees that aren't immediately a cube with our eyes. In fact, we're like, hey, that's a 9th power. Exactly. It's divisible by 3. Just like we have higher order difference of squares that are divisible by 2. If we have a power that's divisible by 3 and it has no remainder, then we have a cube. This is r to the 3rd cubed is equal to r to the 9. So since that's the case, and then 1 can be just 1 to the whatever power, but it's 1 to the 3rd. This is r to the cubed plus 1 cubed. This is a sum of cubes problem. So what we do with that is use our sum and difference of cubes formula, specifically the sum this time, and factor it. So now we have r cubed and 1. And then we have, because again, it's first term, second term. And then it's first term squared, so r cubed squared. And then it's first term times the last term, so it's r cubed times 1. And then you have your last term squared, 1 squared, which is just 1. And then we fill our formula with SOAP. So same, opposite, always positive. So this sign will be a plus sign, this will be a minus sign, and then this will be a always positive plus sign. Now, the concern we have when we start with a higher degree power is that this first factor might have subsequent factoring to perform. We have to take a second look. So this quadratic, the trinomial, it's not a quadratic, but this 6th degree polynomial, this will be done. It won't factor some more. This over here, though, is actually going to be the sum of cubes again. So we have more factoring to do after we write the factored form here. So I'm going to write it, and then I'll bring it up top to factor it some more. So here we've got r cubed plus 1 times, this should be r to the 6th power, minus r to the 3rd plus 1. So the trinomial piece, it won't factor anymore. This piece is another sum of cubes problem in the middle of what was a sum of cubes problem. So we have the joy before us of factoring completely, which means keep going until you can't factor anymore. So what we're going to do is take this r plus 1 up top. Make some space up here. And we've got r plus 1, or sorry, r cubed plus 1 is r cubed and 1 cubed. So that alone, that makes a standalone problem that we do the difference of sum and difference of cubes for. In this case, a sum. So it's going to be first term, last term, and then it's first term squared, first term times the last term, which is r times 1, and then the last term squared, which is just 1 squared. And we fill that in with SOAP, so same sign, opposite sign, always positive sign. So this r plus 1 times r squared minus r plus 1 is what all of this r cubed plus 1 gets to be replaced with. So I need to take my final answer and take this r cubed plus 1 and replace it with this r plus 1 times r squared minus r plus 1. So final answer should be, I'll write it right below here. Kind of moved on me there. That wasn't good. I guess I'll put it to the side. So we'll put it here, r plus 1 times r squared minus r plus 1 times this trinomial on the back, r to the 6th minus r cubed plus 1. So all that, a big long factored form, is my factored completely result. So now we always have to watch whenever you had a higher than 3 power at the second level for another sum or difference of cubes here. And what will be the tell is if you have a third power or something divisible by 3 on both of these two powers, or both of these two terms here in this first part, the linear part, the binomial part, which should be a linear part, the binomial part of the sum and difference of cubes formula. And now we have another one where we have a form of the sum or difference of cubes, in this case a difference, where we've got two nines, and both of them are variables. So we've got cubes, w to the third cubed, minus p to the third cubed. And so since they are the difference of cubes, I can use the formula for sum and difference of cubes, which says I just write a binomial times a trinomial, and the binomial is just the first term, last term, and then it's first term, in the trinomial piece, it's first term squared, and then the first term times the last term, w cubed p cubed, and the last term, p cubed squared. And then you fill it in with SOAP. So that's the form of it. You fill it in with SOAP, the SOAP acronym. Same sign here will be minus, and then the opposite sign over here, plus, and then of course this is always positive in the back. So this trinomial piece, we just need to clean it up, but it'll be done. This first part, just like our previous problem, is actually another difference of cubes factoring process. So I'm going to write w cubed minus p cubed and just kind of wait for that to be done. But I'm going to clean this part up, this trinomial, to be w to the 6th power plus w to the 3rd p to the 3rd, and then plus p to the 6th power. So now all I have to do is factor the w cubed minus p cubed. So I'll write that up top. W cubed minus p cubed is its own difference of cubes formula. These are both cubes, so I'm not going to go through the process of identifying and separating all that stuff. So we're just going to write a binomial times a trinomial. The binomial is first term, last term. The trinomial is first term squared. And then we got the first term times the second term is the middle term. And then the last term squared. So that's the pattern, that's the process, if you look at the formula, that's what it says. And then we fill it in with SOAP. Same sign, opposite sign, always positive sign. So these factors, this binomial times trinomial, needs to go in place of this green w cubed minus p cubed. So I'll write it over here. The whole thing will be w minus p. Actually, I'm going to write it below, right here. So this turns out to be w minus p times w squared plus wp plus p squared, parentheses, and then this blue piece just comes right down, and that's w to the sixth plus w cubed, p cubed, plus p to the sixth. So recognize that this trinomial stayed the same. It was just this binomial that got blown and spread out to be another binomial times trinomial. So the thing progressively gets wider as you factor. All right, we're going to take a look at one more, where this time things are going to be a little bit different because we're dividing our power by 3 and we're going to get an even number. So it's going to affect our second factoring component. So first thing I want to do is recognize that this is a cube. This is 4b squared to the third power. And again, that's because I took the 6, just divide it by 3, and you get 2. So that's where I got that b squared. Minus 1 cubed. So we recognize this is the difference of cubes. So we use the difference of cubes formula, which allows me to write the two terms. In the first binomial, it's just 4b squared, and then a 1. And then in the second one, the trinomial, we're going to get the first term, 4b squared, and you square it. I didn't give myself much room there to square it. And then we've got to multiply the 4b squared times the 1. And then the 1 gets squared. So it's first term squared, multiply the first and last term here in the middle, and then the last term squared. Then we fill it in with our SOAP formula. The SOAP says we just have same sign, opposite sign, always positive sign. So when I clean up this trinomial, that 4b squared is going to turn out to be 16b to the fourth plus this 4b squared times 1 is just 4b squared. And then we have the plus 1 in the back. But this first binomial, 4b squared minus 1, needs to be factored. It's a difference of squares. What I recognize is right after I did the sum of, or the difference of cubes here, sometimes if you have a binomial and there's a square in there or an even power, and these are all squares, you've got to do it. You've got to work through your process for difference of squares, which that formula says you should just be able to square root this, figure out what squared gives you 4b squared, and that should be 2b. And what squared gives you this, 1, is 1. And so this should just be 2b plus 1 and 2b minus 1. And now we have fully factored it. We had a difference of squares pop up at our second layer of a difference of cubes. Now, that's only going to happen for when you're doing the cubes factoring. If the original problem was a difference of cubes, is the only possibility, because you've got to have a difference for the binomial to happen for this to translate to be a difference of squares. And then the other thing that is a tell for when this might happen for you is when you start off, you had an even number that was factorable by 3, or your result of division by 3 is even, gives us the tells that this is potentially a difference of squares formula instead of just sum of cubes, and then difference of cubes, and then another sum or difference of cubes. So that's one other possibility for your factoring completely process.